Everyone, now we are at the last step, that is called a ninth number, finding a reaction force, that how much reaction force is acting on the wall by giving a pull force of 500 kilonewton on our step turned bar. So let's say that how we can do it. It's very simple, that we have to find the R actually. So we can recall the F matrix what we have studied already, that load vector, global load vector, that was R 0 and there was value of 3.125 or 500. So here is the equation for it, that you have to kept as a 10 raised to 4 16u1 and 16u2 is equal to R. Why we are keeping a 61 and 16u2? Because that we are dealing with the element number 1, and element number 1 stiffness was the 16. If you remember, that was a stiffness matrices we have derived, and there was a matrice called K1 was having values 16, negative 16, negative 16 and positive 16. That was the values in it. So from there we have derived it, that 10 raised to 4 16u1 minus 16u2 is equal to R. By solving this parameter, we are getting R is equal to minus 500 cross 10 raised to 3 Newton. And obviously how much reaction force is acting here is that much pull force will be here. So most probably cases you will get the same value as you are having here. So the 500 kilonewton positive, then negative reaction force you will get. So everyone must have understood this thing. This was the last step of the numerical, and if you want to recall that what was the steps we have followed, so let's summarize the steps what we have done for this numerical. So for summary, there are 9 steps we have followed here. So the first step was the discretization, understand the problem we have understood clearly. Then we have did a discretization of the continuum. So for discretization we have divided this part into 2 elements, element number 1, element number 2, node number 1, 2 and 3, displacement number u1, u2 and u3. Last load is called P3, which is 500 Newton. R is called as a reaction, and we have made this kind of element node connectivity table. Then after we have reached to the second step called as elemental stiffness matrices, that to find it out K1 and K2. For K1 there is an equation AE by L. Same equation is getting used for element number 2 also, 1 minus 1 minus 1 and positive 1. Similarly for the element number 2 also, K2 A2E by L, 1 minus 1 minus 1 1. Just keep it, remember that this area is negative and this portion is positive. You will get 2 cross 2 matrix here. Then we have a Hubble stiffness matrix, that means the summation of the K1 and K2. That matrix will come as a 3 cross 3 matrix, and ultimately we are getting this kind of matrix here. Fourth step was global load vector, that is defining the load reaction force, which is here 0 because it is intermediate, and 500 because 500 kilonewton force is acting at the end. So these 3 forces are denoted in the 3 cross 1 matrix. Then fifth and sixth point was global nodal displacement, and K into U is equal to F. So global nodal displacement is called as U1, which is the displacement at this point, U2 which is the displacement at the point of node number 2, and U3 is the displacement at the point end, that is called as a node number 3. And then we have defined K, U and F. So stiffness matrix, displacement matrix and force matrix is here. Seventh step was nodal displacement. That means that previously we had U1, U2 and U3 to find it out, and we are using elimination approach to solve this numerical. So for elimination approaches, let me reply it, that we have cancelled out this top row and first column here, and ultimately we are getting this matrix here. And by solving this matrix using elimination approach, we are getting value of U3 and U2. So in this global nodal displacement matrix, we are replacing these values with the U3 and U2. We are getting this kind of matrix. After that we have reached to the ultimate conclusion for the stresses in the element. For stress in the element, we are finding a stress in the element number 1, stress in the element number 2. So sigma 1 and sigma 2 will be here. The simple equation you have to remember for the sigma 1 is that E by L1 minus 1 into 1 U1 and U2, or simplifying E by L1 minus U1 plus U2. So sigma 1 is 2500 Newton per mm square and sigma 2 will be 3571.33 Newton per mm square. So friends, the ultimate conclusion is that what the sigma 1 and sigma 2 they wanted, it is here. And then reaction force. For the reaction force means that where the bar is fixed, though how much reaction will act on it. So there is a 500 kilonewton force. So obviously the reaction force of minus 500 kilonewton should be acting on it. But to rectify it, to cross check it, what we can do, we can use the stiffness matrix of element number 1, that is called as K1. The value is 16U1 minus 16U2 10 raised to 4 is equal to R. By solving, it is proved that this will be a negative 500 10 raised to 3 Newton value. So this is a complete conclusion of our numerical. We will try to find it out or figure out the new simple ways and solutions to give you an answer for the numerical. Goodbye.